Okay, so today we're going to be talking about Unit 1, Lesson 1. We're talking about like terms in the distributive property. So I filled out these vocab words already. I just kind of want to talk through them and explain what they actually mean. You've heard most of these words before, if not all of them. You would have heard about this in Algebra 1A or possibly even in middle school. So a term is a number, so let's just pick a random number. A variable, and a variable is just like an X or a Y or anything like that. Or the product of a number and one or more variable. So that'd be like saying 7x. So a term is just something, is just one of these three things. Okay, and terms are separated by plus and minus signs. So what that could mean is I could say, let's say 8x squared plus 2x plus 5. Okay, now if I said that this is a term, this is a term, and this is a term, and they're all separated by, in this case, plus signs, but it could be a plus or a minus sign. Okay, constant. So if we look back up, I should have left that green. If we look back up at this example, the constant in that example is 5. Okay, the constant is the term that does not have a variable. So it's the number that stands alone. Okay, then again, if we look back up at that example, I'm going to switch colors again here. Okay, it says the coefficient is the number in front of the variable. So in this case, 8 would be a coefficient, and so would 2 because they're both in front of our variable x. So those are both coefficients. Okay. All right, so then we talk about like terms, and that's what we're going to be combining in this particular lesson. So like terms have exact same variable. So that would be like me saying 7x plus 3x plus 2. Okay, 7x and 3x are like terms because they both have an x. Now, if I said 7x squared plus 3x plus 2, these would no longer be like terms, 7x squared and 3x, because we have an x squared term and we have an x term. Okay, so in order for these to be like terms, we would have to get rid of that. So it would be 7x and 3x. Those would be our like terms in that particular expression. Okay, you can add or subtract like terms by adding or subtracting their coefficients and keeping their exact same variable. Okay, so you cannot add or subtract unlike terms. So we talked about unlike terms being like 7x squared and 3x, but in this particular expression, we have 7x and 3x, which are like terms. So it says you can add or subtract them. Well, since there's a plus sign between the two, we're going to go ahead and we're going to add. So 7x and 3x, we're adding what's in front. 7 plus 3 is 10. It says keep their exact same variable, so 10x. And then that 2, we just leave that because we don't have anything that goes with that 2. That's just our constant. Okay, moving on. So if we look at these few boxes here, it says we need to come up with a number of terms. So the terms are in between our plus and minus signs. So we have 6a squared, our negative 5ab, 3b, and negative 12. So we have 4 different terms. Okay. Then it tells us, well, let's identify those coefficients. So if I'm looking at my coefficients and we go back up to the top here, it says coefficients is the number in front of the variable. So we want to look at this and say, okay, well, 6a squared, that has a variable. So what's the number in front of the variable? It's 6. Negative 5ab, that has a variable ab. So what's in front of that variable? Negative 5. You want to keep that negative sign with that 5. So negative 5, not just 5. Okay, and then you have plus 3b. So we have our b as our variable. 3 is our coefficient. It's in front of that b. Now the negative 12, that does not have a coefficient. That is a constant term. So that actually is what's going to go in that third box. We have a constant, a number by itself of not 12, but negative 12, because there's that negative sign in front. All right, let's look at the second one. So again, our terms, we want to know the number of terms. Our terms are what's separated by plus and minus signs. So each of these is a term. So basically, how many of those terms do I have? Well, I have 5. Okay. Then it says, well, let's identify all the coefficients. So if we look, we have a variable x to the 5th here. The number in front of that variable is 5. So that's my first coefficient. Our second term, we have a variable y. Okay, the number in front of that y is a negative 2. Don't forget the negative. Okay, then we have our next term that has a variable of xy. The coefficient, it doesn't have a number. It looks like it doesn't have a number in front, but we've all heard of that like imaginary 1, because if you multiply anything by 1, you still get itself. So xy times 1 is still just xy. So that coefficient is going to be 1. Then we look at our next term. We have a variable there of x squared, and the number in front of that x squared is 4. Now we do have one term left. It's that negative 1 there. And since it does not have a variable, that is our constant. We don't want to just put 1. We want to make sure that we have that negative sign out front. So negative 1. Okay, moving on to example 1. Excuse me. Okay, it says simplify by combining like terms. So we want to look for terms that are like. So with part A here, we have an x squared and an x squared. Since those are like terms, they both are x squared, we add the coefficients in front. So we say 3 plus 5 is 8. We leave the variables the same, x squared. We do not add it to make it x to the 4th. We simply keep it the same, x squared. Okay, now if we look at B, we have a negative 9w to the 3rd. So I'm going to look at all my other terms and see if there's any more w to the 3rds. And I see one right here. So those are going to be like terms. Okay, so what I'm going to do is I'm going to say, well, negative 9 minus 3 gives me negative 12. I keep my variable the same. And I'm going to go ahead and bring down what's left, that plus wy plus 2y. And I want to look and say, okay, are there any more terms that are like? And looking at this wy, there's no more wy's besides that term. And there's no more 2y's besides the last term. So I'm actually completely finished whenever I say negative 12 w to the 3rd plus wy plus 2y. Okay, then with part C, I have a t and I have another t. So those are like terms. And same as up here with this one right here, negative, there's that imaginary 1 there again. Excuse me again. Okay, so I'm going to say this 3 minus 1 is going to give me 2t. And I'm actually done. I don't have anything else to combine there. Now, D is a little tricky because if you look here, we have 7xy. And we also have 6xy. Well, yes, those are definitely like terms. Okay, the problem that we come across is this last part. It says negative 4yx. Since multiplication is commutative, we actually can say this is the same also because it's really xy. There's still one x and one y. Okay? That didn't really work well. Still one x, one y. Still one x, one y. Just because they're not in the same order, that does not matter. They still have the same number of each variable. Okay? So these are actually all like terms. So we can say 7 plus 6 gives me 13, minus 4 gives me 9xy. And that would be my final answer. Okay. Moving on, I know this is a term we have all heard or should have all heard in Algebra 1A or even in middle school. So we have something called the distributive property. Okay, so we're multiplying the terms outside the parentheses to each term inside the parentheses. So that's whenever we do the little, I don't know, the little arch. I don't know what people call it. Arch and arrow to where we say A times B is AB, A times C is AC. Okay, so we're going to do some examples of that. Like I said, this should all be review. So, with example 2, I'm going to take what's outside my parentheses and I'm going to multiply that by every term inside my parentheses. So I'm going to take 3 times 4m. So 3 times 4 is 12. My m stays the same. And then I'm going to take that 3 and I'm going to multiply it by negative 7. So I get 3 times negative 7 is negative 21. Now I want to look and I want to make sure I don't have any like terms here, so this would be my final answer. Okay. Part B, we're going to take this 2 outside and we're going to multiply it by everything inside. So I'm going to take the 2 times the 5x. 2 times 5 is 10. I keep my x. Then I'm going to take 2 times 3 and I get 6. And if you look here, there are no like terms, so this is actually also finished. Okay. Now, there's no number over here, which is fine. It's just on the other side. So what we're going to do is we're going to take that 1/3. Yes, I know it's a fraction, and I know that we don't like them very much. But we're going to take that 1/3 and we're going to multiply it by 3. Okay, 1/3 times 3 is going to give me 1. And I keep my x. Okay, then I'm going to take that 1/3 times a negative 1. And anything times 1 is itself, so I'm going to get the negative 1/3. And honestly, I'm going to rewrite this because you technically don't need that 1 out front. So it's really just x minus 1/3. If you had 1x minus 1/3, I would not count that wrong. Okay, with the D and E, they're very, very similar. If you notice, it doesn't look like there's a number out front, but again, there's that imaginary 1. Okay, so I really have negative 1 that I'm going to multiply by everything in my parentheses. And if I do that, technically what I'm really doing is just changing the sign. So negative 1 times 5 is negative 5, and I keep that Q. Negative 1 times negative 6 gives me a positive 6. Okay, I have no like terms here, so this is going to be my final step, and I'm complete. Okay, with part E, it's very, very similar. It still has that negative out front, but really there's that -1. And we're going to go ahead and multiply everything by -1, which again, if you notice, it's just going to change everything inside. It's going to change the sign. So -1 times 2x is going to give me -2x. And -1 times 1 is going to give me a -1. Again, no like terms here, so that's my final answer. So with letter F, again, I still have that same thing. I have that negative out front, and I'm going to put the 1 there. Okay, I'm going to say -1 times 2x is -2x. Again, -1 times 1 is going to give me a -1. But this time, I just want to make sure that we know we do not take that -1 times the 4x. It is not in the parentheses. So really that 4x just goes out on the outside still. I'm still going to add it in, but it's not part of those parentheses, so you can't just multiply it by the -1. So I'm going to say -2x plus 4x because those are like terms. Okay, -2 plus 4 is 2. Keep my x, and I have that -1 there that I'm going to keep. With G, this one causes a lot of problems for people because a lot of the time what people want to do is they want to take 6 plus 2 and then distribute that. But we don't want to do that. What we want to do is only distribute what's in front of those parentheses. So let's forget about that 6 for right now. And what we're going to do is we're just going to say 2 times 3x is 6x. And 2 times -1 is -2. Now, we can't forget about the 6 out here. So we're going to say 6 plus all of that. Okay. Now, we don't have any more x terms, so I'm just going to say 6x. But we do have 6 minus 2, which is going to give me a positive 4. And I can't go any further. I have no more like terms. All right. Moving on to example 3. This is the last part. So, write an expression such that if you applied the distributive property to your expression, it would give you the same result presented. Okay, so here's the deal. Whenever we distribute, we multiply. So if we're working backwards, we want to do the inverse operation of multiplication. So we want to divide. So really what we're wanting to do is we're wanting to figure out what goes into both 2 and 4. What's that greatest common factor of 2 and 4? And if we look, the greatest thing that can go into both of those is just a 2. So what we're going to do is we're really going to divide both of these by 2. Okay, we're going to stick the 2 outside the parentheses because that's what we're dividing by. And then we say, well, 2a divided by 2, those 2's just cancel out and we're left with 1a or just a. And then we have -4 divided by 2, which is going to give me -2. Okay, that's all I have to do. All I'm doing is working backwards. So like with part B, we want to look and say, okay, well, what is 5x and 25? What are they both divisible by? And since 5 and 25 are both divisible by 5, I'm going to go ahead and I'm going to divide each of them by 5. 5 would go on the outside of my parentheses. And then I'm going to say, well, 5x divided by 5, those 5's will cancel, and I'm left with x. And then 25 divided by 5 is a positive 5. Okay. With part C, I want to look at 4y and -16 and say, well, what goes into both of those? The greatest thing that will go into both of those is 4. So I'm going to take out a 4, And what I want to do is I want to divide again. 4y divided by 4 would give me just y. Negative 16 divided by 4 gives me negative 4. And you can always check your answer on any of these by going back and saying, well, 4 times y is 4y. 4 times negative 4 is negative 16. And that's what I wanted it to equal, 4y minus 16. So you can always go back and check your answer and make sure that you did it correctly. Okay, so for part D, I'm looking at negative 3x and 12, and I want to see what goes into both of those. And actually, negative 3 will go into both of those. Okay, so I'm going to divide each of them by negative 3, and I get negative 3 on the outside of my parentheses. If I divide, I have x, and 12 divided by negative 3 is going to be negative 4. Okay, again, if I wanted to check my answer, all I'd have to do is multiply or distribute. Negative 3 times x is negative 3x. Negative 3 times negative 4 is a positive 12, which is what I wanted. Okay, that's just checking your work. You do not have to do that. I would recommend it, but you do not have to. Okay, with part F, this one gets a little bit trickier. So part F and part E are probably the hardest problems we're going to do today. So if you look, you have 2x to the 5th, 2x to the 4th, and 2x to the 3rd. They all have a 2 in common. So you can definitely take a 2 out. But you're actually able to take more than that out, because each of these terms has an x in it, and the lowest amount of x's that one of the terms has is x to the 3rd. So I can actually take out 2x to the 3rd. So I'm going to actually write this down here. I'm just going to put that work. That line is not big enough. So I'm going to take out a 2x to the 3rd. And if I do that, the 2's cancel. And x to the 5th over x to the 3rd, what you do, this should have been something from Algebra 1A, hopefully that you guys remember. But what you do with the variables whenever you're dividing, what you do with the exponents whenever you're dividing is you subtract the exponents. So I'm going to take 5 minus 3, and that's going to leave me with x to the 2nd. Okay, again, these 2's cancel, and I can say, well, 4 minus 3 is going to be 1, so I'm going to say plus x to the 1st, or really, I just want to put x. Okay, that x to the 1st is the same thing as x. And then this last part, if I take 5 divided by 5, it gives me 1. Okay, so anytime I'm taking something and dividing it by itself, it's going to give me 1. So 2x to the 3rd over 2x to the 3rd is also going to do that. It's going to give me 1. Okay, then we have E, okay? And with E, it's very similar to part F. So we have 5x to the 10th, 5x to the 5th, and 15x squared. So if you look at 5, 5, and 15, those numbers are, all of them are divisible by 5. Okay, so I'm going to have a 5 here. And then if we look at the variables, the lowest variable that I have here is an x squared, so I'm going to take that out also. So I can take out a 5x squared. And if I take out a 5x squared, the 5's cancel here. X to the 10th over x squared, I'm going to take that 10 minus 2, and I get x to the 8th. 5's cancel here. I'm going to take the 5 minus 2, and I get plus an x to the 3rd. And then 15 divided by 5 is actually 3. And the x squareds, they cancel. Okay. So that would be my final answer. And it looks like that is actually it for lesson 1 of Unit 1.